Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey will take us through 50 strange and wonderful truths about our solar system. Facts so unusual, they might sound like something from a science fiction novel. But every one of them is grounded in real science. No exaggerations, no embellishments, just the universe being its mysteriously honest self. But before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe, only if you truly find these quiet explorations enjoyable. And when you're ready, leave a comment to let me know where in the world you're listening from and what time it is for you right now. It's always such a joy to see all the places we gather from, each in our own little slice of time. Now feel free to dim the lights, maybe turn on a fan for a soft background hum, and let's gently begin our journey through the solar system together. And if your mind begins to wander, that's perfectly fine. Let it drift. We'll still be here, quietly unfolding the story. You see, there's something almost magical about space. Not the booming rockets or flashy images you see in science fiction, but the real thing. The silent, slow-turning ballet of planets around a star. The delicate whisper of gravity, holding everything together in a dance that's lasted billions of years. It's vast but not empty. Cold, yet full of stories. Familiar, but always a little beyond our reach. When we talk about the solar system, we tend to think of textbook diagrams, neat circles labelled with Latin names, each planet spaced politely from the sun. But in reality, our solar system is anything but tidy. It's a sprawling, chaotic, deeply beautiful place. A system filled with eccentric orbits, tilted axes, sideways spins, storms that last for centuries, and moons that shoot geysers into space. It's a place where diamonds might fall as rain, where ice hides under burning skies, and where entire planets spin like they're trying to nap sideways. And perhaps what's most delightful of all is how often the truth is stranger than the fiction we once imagined. We used to dream of faraway worlds with alien seas and mysterious weather. And then we discovered Titan, a moon with rivers and lakes made of methane. We imagined volcanoes on distant lands and found them, erupting on moons like Io. We pictured silent planets, forgotten by time, and saw Neptune, howling with winds faster than sound. But even if these facts are extraordinary, tonight we won't be shouting about them. No dramatic soundtrack, no rapid-fire countdowns. Just a slow, quiet wander through a cosmic backyard filled with peculiar details. Like peeking into an attic you never quite realised you had, and finding it full of curiosities. Throughout this journey, we'll travel from the sun's blazing core to the icy edge of the Oort cloud. We'll stop beside worlds both famous and forgotten. We'll visit the familiar, Earth, Mars, Saturn. But we'll linger on the overlooked too, on moons with wild weather and asteroids with secret stories. We'll look not just at the big things, but the strange ones. The things most likely to make you pause and whisper, "Wait, really?" And just as important, we'll make sure this journey is gentle. There's no exam waiting at the end. No need to remember the names of moons or chemical compositions unless you want to. Let it all wash over you like starlight, soft, slow, and steady. If you fall asleep halfway through, that's perfectly fine. In fact, that's part of the design. Because sometimes learning works best when the mind is quiet. When you're not trying too hard to hold on, and instead just letting go, allowing the wonder to settle softly in the background of your thoughts, like the ticking of a clock you forget is there, or the quiet creak of your house as it settles in for the night. And in a way, that's what space does too. It doesn't ask for attention. It just is, slowly spinning, orbiting, changing over time spans we can barely comprehend. It continues quietly, whether we're awake or asleep. So tonight, let's become part of that rhythm, drifting gently from one strange truth to the next. With each fact, we'll add a tiny star to the sky of your imagination. And whether you remember just one or none at all, it's okay. The story will still be there, softly looping through the night sky. Now, take a deep breath. Let your shoulders drop. Close your eyes if you like. The journey is about to begin. We'll start at the centre, with the sun. Not just a ball of fire, but a gravitational monarch, a constant, a giver of time and life and strange magnetic tantrums. But we'll get there in a moment. For now, all you need to do is rest. The universe is vast, and tonight you're floating gently through it. If you were to step outside just for a moment and look up into the night sky, you might feel a quiet sense of comfort. Maybe you've seen that sky before. The moon in its usual place, a scattering of stars, perhaps the familiar dip of Orion's belt or the slow arc of a passing satellite. It all feels known, familiar, as though the solar system is a kind of neighbourhood, one that we've lived in all our lives, and in a way it is. But like any neighbourhood, the closer you look, the stranger the houses become. The more time you spend here, the more you realise this isn't just a familiar place, it's an impossible one. We call it our solar system, a name that suggests simplicity, order, even domesticity. As though it were a tidy diagram on a classroom wall, with planets neatly spaced like pearls on a string. But in truth, it is neither tidy nor simple. Our solar system is vast and dynamic, a family of misfits and extremes, a collection of spinning worlds and icy wanderers, each with their own peculiar rhythm, each one quietly orbiting a star that seems unchanging, but in reality pulses, flares and breathes with magnetic storms of its own. At the centre of this family sits the sun, a glowing sphere of plasma that holds everything else in its grasp. It may look peaceful from Earth, just a warm circle in the sky, but the sun is unimaginably massive. It contains 99.86% of the total mass of our solar system. Everything else, the planets, the moons, the asteroids, the comets, even all the spacecraft we've ever launched, they make up less than a fraction of a single percent. In terms of mass, the solar system is not a collection of planets circling a star. It is a star with a few trinkets caught in its field, and yet, for all its dominance, the sun is not the centre of every story. The planets have tales of their own, ones that don't always revolve around brightness or heat, but around ice, storms and improbable coincidences, around moons that hide oceans beneath their crusts, around storms that never die, around planetary tilts so dramatic they turn the seasons into decades. As the sun burns on, the entire solar system is hurtling through the galaxy at a breathtaking speed, around 828,000 kilometers per hour. That number might feel abstract, but imagine this. Every hour, we travel the distance from London to Sydney more than 60 times. And yet, we never feel it. No wind rushes past our ears. No cosmic breeze ruffles our hair. Space is silent. It does not announce its speed. This immense journey takes us on a slow, elliptical path around the centre of the Milky Way. A journey so long it has its own name, a galactic year. One complete orbit takes roughly 225 to 250 million Earth years. That means the last time the Sun was in this position around the galaxy, there were no humans, no mammals. Even the dinosaurs were a relatively new experiment. You, listening now, are riding a planet that has made only 1 or 2 laps around the galaxy in all the time life has existed on Earth. It's not just humbling, it's surreal. But for all that speed, from here everything looks so calm. When we gaze at the night sky, we don't see chaos, we see stillness. The stars don't streak by. The planets don't wobble in our vision. The solar system has the still beauty of a snow globe, moving furiously, but appearing to float in silence. And that illusion is part of the wonder. Even our closest neighbours are far stranger than they appear. Take Mars, dry and rust-coloured, hiding signs of ancient riverbeds, and perhaps even buried ice. Or Venus, which looks like Earth's twin but is hotter than a pizza oven and spins in the opposite direction. Or tiny Mercury, scorched on one side, frozen on the other, yet hiding ice in its shadowed craters. As we'll see throughout this journey, nothing in this system is as it seems. Moons behave like planets. Some asteroids have their own satellites. Planets spin sideways. Ice exists where it should melt, and warmth glows where only cold should live. The more we learn, the more the diagram unravels, the more the textbook shrugs and says, well, it's complicated. And yet we still call it our solar system, not just in a scientific sense, but in a deeply personal one. It is ours in the way a childhood home is yours, not because you built it, but because you grew within it. Every atom in your body was born here, forged in stars that lived and died long before the sun, shaped by gravity, time and chemistry into skin, breath and memory. So when we talk about the solar system as home, we're not being metaphorical. We're part of this system in the most literal way possible. We belong to it, and as we move forward, through rings and storms and icy fringes, that belonging will only deepen. You don't have to remember every name or fact. Just let each one drift by, like a planet in the distance, spinning quietly, glowing softly, impossibly real. Let's continue. The next time someone says, "You couldn't make this stuff up," we'll kindly disagree. Because the universe already did. There's a quiet kind of joy that comes from realizing the universe doesn't need to exaggerate to surprise us. We often look to science fiction for stories that bend the rules of nature, invent new worlds, or stretch time and space into impossible shapes. But the truth is, if you know where to look, the solar system does all of that on its own, without scripts or special effects. It simply is strange, and perhaps that's why we don't always notice. Because the most unbelievable facts are often the ones hidden in plain sight. Let's start somewhere simple. Mercury. A planet so close to the Sun, you'd assume it's an oven from pole to pole. But look a little closer, and you'll find something unexpected nestled inside its most shadowed craters. Ice. Yes, actual water ice. In places where the Sun never reaches, the bottoms of deep impact basins near the poles, ice has managed to survive for millions, maybe billions of years. Despite being the closest planet to the Sun, Mercury preserves pockets of ancient frost, as if it's hiding tiny secrets where the light can't touch. Now drift outward a bit, toward our own moon. It's easy to think of the moon as a fixed presence in the sky, a constant, a companion. But it's not as still as it seems. Every year, the moon drifts about 3.8 centimetres farther away from Earth. That's roughly the rate your fingernails grow. It's so slow you'd never notice, but over time it adds up. Hundreds of millions of years from now, solar eclipses will be different. The moon will no longer perfectly cover the sun. A gentle reminder that even the most familiar parts of our lives are in motion, quietly slipping away. And then there's Saturn, the crown jewel of the outer planets. You've seen its rings in photos, maybe imagined what it would be like to float above them. But here's the part that feels like fiction. Saturn is so light, relative to its size, that if you had a bathtub large enough, it would float. That's not poetic imagery. Its average density is less than that of water. Of course, no one has a bathtub big enough for Saturn. But if they did, you'd see a planet the size of 760 Earths, bobbing gently on the surface, like a golden balloon made of gas and wind. While Saturn drifts in elegance, Mars rages with storms. Not quick tempests, like we might see on Earth, but dust storms that can cover the entire planet. These storms begin with a whisper, a few grains lifted by sunlight-warmed air, and can grow into whirlwinds that stretch across continents, then the globe. Visibility can drop to almost nothing. Solar panels on rovers become coated in fine red powder, and the storm doesn't pass in a day. It can last for weeks, sometimes months. To stand on Mars during one of these tempests would be like standing in a bowl of swirling rust. all light faded to orange, all sky hidden by dust. And while we're thinking of storms, let's visit Jupiter, where one of the most famous tempests in the solar system has been spinning for at least 350 years, maybe much longer. The Great Red Spot isn't just a weather event. It's a permanent feature of the planet's atmosphere, a storm so large you could fit 2 or 3 Earths inside it. It's a swirling, churning monument to longevity. Imagine a hurricane on Earth, except it never dies. It feeds on surrounding currents, fueled by unknown forces, shifting in size and shade but refusing to vanish. We don't know exactly how it began, or why it persists. It just is. A swirling eye carved into the face of a gas giant older than most of our history. When placed together, these facts begin to shift our sense of what's normal. Ice on Mercury, a floating Saturn, a shrinking moon, a dust-covered Mars, a storm older than the United States. They sound like details from a surreal novel, but they're not. They're quiet truths, witnessed by telescopes, confirmed by missions, and whispered into textbooks that barely seem to capture their wonder. You might be tempted to ask, how can these things be true? How can a solar system that feels so still, so ordinary from our tiny vantage point, be full of these extraordinary events? Part of the answer lies in time. The solar system doesn't rush. It doesn't crash and bang like the movies often show. It moves with patience. Change is measured not in weeks or years, but in centuries, millennia, eons. Storms are allowed to evolve. Planets are given time to shrink or shift. It's not chaos. It's something deeper, something like rhythm. And part of the answer lies in contrast. Earth is special, yes, but not because it's the only planet with stories. Rather, because we've had the time and tools to listen. As our spacecraft reach farther and our sensors become more sensitive, we're finally beginning to notice the quiet murmurs of the rest of the system. The groans of crusts cracking, the hum of magnetic fields, the flicker of dust against alien sunsets. The more we look, the more strange the solar system becomes. So tonight, let's continue looking, slowly, gently. Let each bizarre truth settle in like a pebble in a pond. Let the ripples carry you to the next thought. Because as strange as these facts may seem, they are real, realer than fiction, quieter than fantasy, and far more persistent. And that is what makes them beautiful. If you picture the solar system as a vast ballroom, the planets are the dancers. Some glide in close circles near the centre, others sweep wide arcs near the edges, but all of them move in tune with an invisible rhythm. This rhythm, this choreography, isn't driven by sound or light, but by gravity. And while gravity may be the most familiar of forces, in the vacuum of space it becomes something stranger. It doesn't just pull, it shapes, it organises, it creates sanctuaries of stillness and highways of motion, hidden from view, but quietly guiding every object, every orbit, every whisper of dust. Let's begin with something subtle, a kind of gravitational harmony that doesn't appear on star maps or in backyard telescopes. These are the Lagrange points. Imagine 2 massive bodies, like the Earth and the Sun, locked in a gravitational embrace. Between them, and around them, there are pockets where the gravitational pulls of the 2 bodies perfectly cancel out the motion of a third, smaller object. These points are like balance beams in space. If you place something there, a satellite, a telescope, even a particle of dust, it can stay put with minimal effort, coasting in equilibrium. There are 5 of these points in the Earth-Sun system. L1 sits between Earth and the Sun, and it's where we position solar observatories like the SOHO spacecraft, which keeps watch over solar storms and flares. L2, just behind Earth from the Sun's perspective, is where we've placed the James Webb Space Telescope, a delicate eye that must always face the deep dark, shielded from the sun's glare. It floats there in perfect balance, in a kind of shadowed cradle of gravitational geometry. But these points aren't just useful, They're poetic. They show us that even in the chaos of planetary motion there are places of quiet, points of pause. It's as though the solar system has resting spots built into its dance, places where you can stop and look around without being swept away. And then there are the Trojan asteroids, strange little companions that ride along with planets, tucked away in the leading and trailing Lagrange points of their orbits. Earth has them, though they're hard to see. Jupiter has thousands, some of them hundreds of kilometers wide. They share the planet's orbit but never collide with it, moving in locked positions like well-trained partners in a cosmic waltz. These aren't rogue rocks or wandering debris. They're permanent residents, silent, unseen, and perfectly balanced. The existence of these gravitational niches reminds us that space isn't just empty, it's textured. Not with matter, necessarily, but with influence, a field of unseen nudges and quiet channels. Gravity carves invisible grooves through the void, and everything that drifts through them follows paths shaped not by chance, but by a web of forces stretching across millions of kilometers. Even far beyond the known planets, these patterns persist. There is a place, at the very edge of the sun's reach, where the gravitational pull becomes soft, not gone, but diluted by distance. This is where we believe the Oort cloud begins, a vast icy shell surrounding the solar system, filled with comets and fragments left over from its birth. We've never seen it directly. It is too far, too diffuse. But we know it must exist, because long-period comets, the ones that take thousands of years to return, come from somewhere. They appear suddenly in the sky, blazing through the inner system, and then vanish again for millennia. Their paths are not random. They are pulled in from the outer dark by gravity's long fingers. What's strange is how little force it takes to alter their journeys. A passing star light years away can nudge a comet inward. A shift in the sun's motion through the galaxy might disturb the cloud's outer edge. Even gravity, it turns out, is a patient artist. It waits, and when the moment is right, it rearranges the pieces. And all of this, the Lagrange points, the Trojans, the comets from the edge, teaches us a quiet lesson. That motion in space is never truly alone. Every orbit is part of a greater web. Every movement is a response to something unseen. The solar system is not a collection of isolated planets doing their own thing. It is a choreography, an endless, ever-adjusting performance in which every dancer responds to the music of mass and distance and time. Even the spacecraft we send must obey this choreography. When we launched the Voyager probes, or when we charted courses to the outer planets, we relied on gravitational assists, swinging past planets to steal a bit of their momentum. These weren't accidents. They were calculated slingshots, a way of using the dance rather than fighting it. And there's something beautiful in that. We tend to think of space as a place of brute force, rockets blasting off, planets colliding. But the more we learn, the more it seems that the real story is one of subtlety. The solar system is not loud. It's a whisper, not a race, but a drift. The planets don't crash through space. They coast, they glide, they follow paths carved by gravity's invisible hand. Tonight, as you close your eyes, imagine the solar system not as a chart in a book, but as a vast stage. Stars on the backdrop, planets sweeping slow arcs, moons following like children behind their parents, and far in the wings, comets watching from the dark. Somewhere between Earth and the Sun, an observatory hangs in balance, and behind us, a great telescope peers quietly into forever. All of it in motion. All of it at rest. Every family has its odd ones out. The quiet uncle who lives in the woods, the cousin who collects something obscure, the relative who doesn't quite follow the expected rhythm. And in the family of our solar system, these characters are not just present, they are numerous. They fill in the spaces between planets. They linger on the edges. They are strange, inconsistent, and often overlooked. But they matter. because in many ways they are the remnants of everything that came before. They are the leftover puzzle pieces, the parts of the picture that didn't quite fit into the neat planetary frame, but still belong to the story. Between the orbits of Mars and Jupiter lies a region that many people imagine as a crowded, dangerous place, a tumbling field of rocks crashing into one another, the asteroid belt. But the truth is far less dramatic. If you were to travel through the asteroid belt in a spacecraft, you might not see a single asteroid for days. It's mostly empty. The rocks are far apart, separated by vast distances, quietly orbiting like forgotten clocks ticking in an abandoned hall. And yet, some of these asteroids are remarkable. One of them, Ceres, is large enough to be called a dwarf planet. Discovered in 1801, it was once considered a planet, before astronomers refined their definitions. Ceres is not just a dusty rock. It has a shape sculpted by gravity, a surface dusted with salts, and evidence of recent geological activity. Bright patches have been spotted on its surface, reflections of salty deposits, likely left behind by briny water that once seeped up from underground. In the cold silence of the asteroid belt, something stirred, and even now it may not be entirely still. Beyond Neptune, the puzzle pieces get stranger. Out here, the sun is little more than a bright star, and the planets give way to a realm of icy bodies, remnants from the solar system's earliest days. One of these is Haumea. At first glance it sounds fictional. It's shaped like a rugby ball, spinning so fast that it's been stretched out by centrifugal force. A day on Haumea lasts just under 4 hours, one of the fastest rotations of any known large object in the solar system, and it has a ring. Not as grand as Saturn's, but still, a thin, icy loop orbiting a misshapen world, far from the sun. These objects challenge our idea of what a planet should be. They're not spherical. They don't clear their orbits. Some of them haven't even been seen clearly, just tracked by how they tug on other things. But they're out there, forming a sort of ghostly border around the planetary family, an extended family of eccentric shapes and slow-moving secrets. And then there are the comets, icy time travellers that come streaking in from the deep, leaving long glowing tails in their wake. A comet is often thought of as a ball of ice and dust, but when it approaches the sun, it becomes something else entirely. The heat causes the ice to sublimate, turning directly into gas, and as the gas escapes, it carries dust with it, forming a glowing coma, and then a tail that can stretch millions of kilometers into space. It's not that the tail is chasing the comet. Rather, the sun pushes it away, using light and solar wind as invisible hands. Some comets return often. Others take thousands or even millions of years to come back, if they return at all. They emerge from the Kuiper belt or the Oort cloud, blazing briefly into the inner solar system like sparks from a distant fire. And then they're gone. Their presence is a reminder that not everything in the solar system is on a predictable path. Some stories pass through once and never again. Further in, but still strange, is Pluto, perhaps the most famous of all the leftovers. Once the 9th planet, now a dwarf planet, Pluto has a story that many people know in name but not in detail. It's not just a frozen ball of rock. Pluto has mountains of water ice, a thin atmosphere that expands when it's closer to the sun, and glaciers of nitrogen that appear to flow, freeze, and reshape the surface. It even has a heart-shaped region, a broad light-coloured plain named Tombaugh Regio after Pluto's discoverer. It's quiet, distant, and cold, but it is not lifeless. In 2015, the New Horizons spacecraft flew past Pluto and revealed a world more complex than anyone expected. Pluto also has a companion, Charon, its largest moon, so big relative to Pluto that the two actually orbit a point in space between them, rather than Pluto being the clear dominant body. It's a binary dance, not a planet with a satellite, but two worlds locked in mutual orbit. And that too is a kind of leftover elegance. something unexpected, unbalanced, but no less real. All of these objects, the asteroids, the dwarf planets, the icy visitors, remind us that the solar system is not just made of big things, not just the giants with rings and storms, or the rocky spheres with atmospheres and moons. It is also made of edges, of fragments, of half-finished stories, of puzzle pieces that didn't get placed but still belong. And maybe, as you listen to these fragments, you'll begin to feel their presence more clearly, in the soft shimmer of comet dust across the night sky, in the silent passage of an asteroid just beyond the reach of vision, in the cold gleam of a distant world reflecting sunlight that left the sun 5 hours ago. The solar system isn't tidy, it's not finished, it's not symmetrical, but like a box of scattered puzzle pieces, it's still beautiful, especially when you realise some of the most fascinating parts are the ones left at the edges, waiting to be noticed. If planets were people at a dinner party, Mercury would be the one who speaks rarely, but listens to everything. The one sitting nearest to the fireplace, quiet and scorched by proximity, yet oddly composed. Venus, meanwhile, would be the mysterious guest who arrives late, moves in the opposite direction of the room's chatter, and says something once, just once, that no one ever forgets. These two worlds live side by side, closest to the Sun, but they could not be more different in temperament, history, or the ways they defy our expectations. Mercury first, the smallest planet in the solar system. No air to breathe, no clouds to catch the light, no rings, no moons. And yet it endures. It circles the Sun every 88 Earth days, dancing swiftly in a long egg-shaped orbit that brings it closer to the Sun than any other planet. You might imagine that it is nothing but scorched stone, a furnace from pole to pole. But you'd be wrong. In the deep shadows of craters near its poles, places where sunlight never reaches, scientists have found water ice. Yes, ice, on Mercury. This isn't the soft frost that dusts your window on a winter morning. It's ancient, unmoving, and hard as stone. It hides in the silence, undisturbed by warmth, because no warmth ever gets that far. These craters are eternal pockets of shadow, black bowls carved into the surface, preserving a memory of water even in the Sun's front yard. And Mercury itself is changing, slowly, quietly. Over the last few billion years, its surface has shrunk. As the planet's core cools, the crust wrinkles inward, forming cliffs and ridges. Imagine an old apple, once round and firm, now withered just slightly, its surface folding in subtle creases. From Mercury's sparse solitude, we drift outward to Venus, a planet of paradoxes. It is nearly the same size as Earth, made of similar rock, likely began with similar ingredients, but somewhere along the way everything went wrong. Venus is hotter than Mercury, despite being farther from the Sun. Its thick atmosphere traps heat with terrifying efficiency, a runaway greenhouse effect that has turned it into a world of choking clouds and lead-melting temperatures. The surface reaches nearly 470 degrees Celsius. It is hot enough to dissolve dreams, yet long ago there may have been oceans. Venus might once have had water on its surface, rivers carving paths through volcanic plains, lakes reflecting the strange yellow light of its thick atmosphere. Some models suggest that for hundreds of millions of years Venus was habitable, not just survivable, but Earth-like, until something tipped the balance. Perhaps too much carbon dioxide, perhaps the loss of a magnetic field, perhaps time playing its slow, cruel hand. Whatever the cause, the oceans boiled away. The water escaped, and the planet sealed itself in a blanket it could no longer take off. Even its rotation defies intuition. Venus spins backward, retrograde, meaning the sun rises in the west and sets in the east. And it spins so slowly that a single day, one full rotation, is longer than its year. It takes 243 Earth days to rotate once on its axis, but only 225 days to orbit the Sun. That means if you stood on Venus at sunrise, you'd wait almost an Earth year before the Sun returned to the same spot in the sky. But don't try it. Even the most advanced probes we've sent have been crushed and melted within hours. Still, there is beauty here. Not the kind we recognise easily, not oceans or forests, but something deeper, a kind of melancholy grandeur. Thick clouds laced with sulfuric acid swirl in slow motion above a lava-scarred surface. The entire planet turns in its own direction, on its own terms, as if caught in some ancient reverie. It is chaos, yes, but it is motionless chaos. A planet stuck in a moment it cannot escape, reliving a story whose beginning is known but whose end is always just out of reach. And there's something haunting in that, in how two planets so close to Earth could be so unforgiving. Mercury, quiet and shrinking, hiding ice in the corners of its scorched face. Venus, blazing and veiled, spinning the wrong way under an oppressive sky. Neither is welcoming, neither is kind. And yet they teach us something by contrast, about balance, about chance, about how thin the line can be between a world that sustains life and one that smothers it. As you drift tonight, let these worlds keep spinning. Imagine Mercury's shadows, never touched by dawn. Picture Venus wrapped in yellow haze turning backward in its sleep. No storms roar, no rivers run, but still they move. Still they orbit. Still they are part of the rhythm. In the silence between them, Earth waits, the next stop on our journey. But for now, rest in the stillness. Let the heat of Venus and the hush of Mercury hold your thoughts like bookends at the edge of a long quiet shelf. Among all the planets in the solar system, Earth is the one we know best. And yet in many ways, it's the one we understand the least. Not because it's unfamiliar, but because it feels too familiar. We walk its soil, drink its water, breathe its air, and rarely stop to wonder how improbable it all is. Earth feels inevitable, but it isn't. When you begin to look at the facts one after another, a strange pattern starts to emerge, not of certainty, but of delicate chances strung together. And together, they form a machine built not of gears, but of accidents. A coincidence machine. Start with something as ordinary as our tilted axis. Earth doesn't spin straight up and down, its axis is tilted at about 23.5 degrees. This one small slant is the reason we have seasons. It means the sun's light isn't always evenly spread, so the northern and southern hemispheres take turns basking in warmth or curling into cold. Without that tilt, we wouldn't have the changing arc of the sun across the sky, or the rhythmic shifts in temperature and light that mark the passing of months. It's a quiet angle, but it gives shape to time. That tilt, by the way, is stabilised by the moon, a companion so perfectly placed, it's easy to forget how strange it is. The moon is unusually large compared to Earth, much larger than any other moon-to-planet ratio in the solar system. It's so perfectly positioned that during a total solar eclipse, it can completely cover the sun's disk, creating a corona of light around a perfect black circle. This isn't just poetic, it's geometrically astonishing. The moon's size and distance happen to match the sun's apparent size from Earth almost exactly. Not too small, not too large, just right. But more than beauty, the moon gives us stability. It acts as a gravitational anchor, dampening the wobbles in Earth's rotation that might otherwise swing our climate into chaos over long timescales. Then there's the magnetic field, an invisible armour wrapped around the planet. Deep inside Earth, molten iron moves in slow, swirling currents, creating a dynamo that generates a magnetic field extending far into space. This field deflects solar wind, streams of charged particles constantly flowing from the sun. Without this protection, the solar wind could gradually strip away our atmosphere, as it likely did to Mars. Our magnetic field doesn't just exist, It pulses and breathes with the planet, occasionally flipping direction in long cycles, quietly guarding us from radiation most of us never think about. And still, beyond that, another layer of shielding, the heliosphere. It's not something Earth creates, but something we benefit from. The heliosphere is a giant bubble blown by the solar wind, stretching far beyond Pluto's orbit. It acts as a kind of cosmic force field, protecting the solar system from interstellar radiation and cosmic rays. Think of it like an umbrella that the sun holds open, not just for itself, but for all of us. A fragile dome that softens the edge of space. Even Earth's orbit adds to the picture. It's not a perfect circle, but it's close enough. Just slightly eccentric, meaning slightly oval. That tiny deviation, not too much, not too little, gives Earth gentle fluctuations in distance from the Sun, which combine with the axial tilt to create the complex layering of seasons. If the orbit were more stretched, the seasons might become wild swings. If it were perfectly circular, they might fade altogether. Instead, we have a pattern that dances, not because someone designed it, but because the numbers happen to fall that way. And there's atmosphere, not too thick, not too thin, dense enough to trap warmth, light enough to breathe, rich in nitrogen and oxygen, with just enough carbon dioxide to hold heat, but not so much as to choke the sky. A mix that supports fire and rain, breath and cloud, wings and waves. It even filters ultraviolet light through a thin layer of ozone, letting the blue in while shielding us from the worst. Take all of these together, and you begin to see Earth not as a default, but as a lucky intersection. A confluence of ingredients that, if changed slightly in any direction, might have rendered it hostile or inert. And yet here it is, spinning gently, tilted just enough, guarded by fields seen and unseen, warmed not too much and not too little. Even the timing matters. Earth formed at a time when the galaxy was already rich in heavy elements, seeded by supernovae from stars that lived and died before ours. The metals in our blood and bones, the iron, the calcium, are the gifts of these ancient explosions. The carbon in your breath, the oxygen in your lungs, all forged in stars long before the sun lit up. So when you breathe, when you lie still, when you feel the turning of a season or the coolness of a breeze, you're experiencing not something that was planned, but something that worked, improbably, wonderfully, softly. Earth is often called the Goldilocks planet, not too hot, not too cold. But maybe that phrase misses the wonder. It's not just that Earth is just right, it's that it didn't have to be. There were so many other ways it could have turned out, and yet, here we are, watching eclipses, planting trees, writing poems, and drifting off to sleep while listening to a voice talk about magnetic fields and moonlight. Tonight, as you rest, let Earth feel a little stranger, and a little more precious. Not just because it holds you, but because it almost didn't. It didn't have to be like this, but somehow, against the odds, it is, and that may be the quietest miracle of all. Mars is often called the Red Planet, but that name, while visually accurate, hardly tells the whole story. Red is just the surface. What lies beneath is memory. Mars is a world filled with absence, not emptiness, but a kind of ghost story written in valleys, channels, and mineral traces. It's the planet that looks dry, but remembers being wet. A planet shaped by forces that no longer operate, by rivers that no longer flow, and by a time when it may have been something much more familiar and much more alive. The surface of Mars is carved with features that, at first glance, feel impossible on a planet without liquid water. There are riverbeds, long winding valleys that look as though they were carved by the patient persistence of flowing streams. There are deltas, where ancient rivers once spilled into lakes, fanning out like fingers of sediment. These aren't small features. Some of them stretch for hundreds of kilometres, clear as day, in orbital images, like dry scars left by ancient veins. Then there's Valles Marineris, a canyon system so enormous that it defies easy comparison. It runs for over 4,000 kilometres, about the width of the continental United States, and in some places it plunges 7 kilometres deep. If it sat on Earth, it would stretch from New York to Los Angeles and swallow the Grand Canyon several times over. The cause of its formation is still debated. Tectonics, volcanic stretching, and erosion may all play a role. But whatever the origin, it is a gash in the planet, a reminder that something powerful once moved here. Further west stands Olympus Mons, the tallest known volcano in the solar system. Its base is wider than the entire state of Arizona. Its summit towers 22 kilometres high, nearly 3 times the height of Mount Everest. But what makes it truly strange is not just its size, but its stillness. Olympus Mons is thought to be dormant, not extinct. Mars lacks the tectonic plates that spread volcanic hotspots across the surface, so a single plume of magma can build and build in one place, layer after layer, without moving. And so Olympus Mons grew, patiently, silently, into the tallest mountain we've ever found. But perhaps the most haunting part of Mars is what it no longer has. Evidence points to vast quantities of water in its past, not just flowing on the surface, but potentially pooling into oceans. Some estimates suggest that if all the ancient water were gathered, it could have covered the entire planet in a global ocean hundreds of meters deep. Today, that water is gone. Some of it is frozen in the polar caps. Some of it may lie underground, trapped in permafrost or perhaps even in pockets of briny liquid. But most of it, the vast seas and lakes, has vanished into the air and space. You can still see the traces. The Mars Reconnaissance Orbiter has captured dark streaks on crater walls and slopes, features known as recurring slope lineae. They appear and disappear with the seasons, and while they may not be liquid water in the traditional sense, they suggest that briny, salty flows may still occur under just the right conditions. They are ghost trails, shadows of motion where life-giving fluid may once have whispered down dusty rock. And the sky of Mars. It doesn't behave quite like ours. Sunsets here are blue, not red. During the day, the skies are dusty pinkish orange, but when the sun sets, the thin atmosphere scatters light differently. Blue light, normally scattered away on Earth, travels straight through on Mars, creating a surreal reversal, a blue evening on a red world. Add to that the dust devils, towering columns of swirling sand, hundreds of meters tall, wandering across the plains like nomads, and you have a sky that moves in whispers and silence. Mars's atmosphere today is thin and fragile, only about 1% as dense as Earth's. It cannot hold heat well, which means the temperature swings are extreme. It cannot shield against radiation, which makes the surface hostile. But it wasn't always like this. Long ago it may have had a thicker atmosphere sustained by a magnetic field, but that field disappeared, likely due to the cooling of the planet's core, and when the shield fell, the solar wind began stripping the atmosphere away, slowly, relentlessly, like wind eroding the face of a statue. What remains is a world that feels paused, not dead exactly, but arrested, incomplete. There's a certain melancholy to Mars. It seems to be forever caught between identities, not quite a frozen wasteland, not quite an Earth-like twin. It's as if the planet tried once to become something more. It had rivers, perhaps even oceans. It had warmth and seasons and chemistry. But something changed, and now it waits. We see in it not only the story of a distant world, but the story of potential, of how close a planet can come to being something else. And still it holds us in fascination. Rovers trundle across its surface, leaving soft tracks in the dust. Orbiters scan for patterns in the terrain. Scientists debate what lives, or once lived, beneath the soil. And people dream of going there. Not just to visit, but to stay. Perhaps one day they will, and perhaps walking through ancient valleys under a salmon sky, they'll feel not alone, but welcomed. As if Mars in its silence had been waiting all along. So tonight let Mars linger in your thoughts. Let its blue twilight settle gently over your imagination. Let the wind whisper across long dead riverbeds, and let Olympus Mons sleep in peace. Not all memories need voices. Some are written in stone, in slope, in silence. And Mars remembers, even if we're just learning how to read. There's something about Jupiter that makes you pause, not out of fear, but awe. It is the largest planet in our solar system by far, a gas giant so massive that if it were twice as heavy, it might have ignited into a second star. More than 11 times wider than Earth, more than 1,300 times our volume, Jupiter is less a planet and more a gravitational presence. A monarch that doesn't just orbit the Sun, it shapes the orbits of others. But for all its weight and might, Jupiter's story isn't only about size, it's about storms, guardianship, and the strange beauty of motion that never stops. When you look at a photograph of Jupiter taken by telescopes or passing spacecraft, what stands out most is the texture. Unlike the solid planets with their dry plains and sharp features, Jupiter is a planet made almost entirely of gas, hydrogen and helium, layered in thick coloured bands that swirl and shift like painted wind. There are no mountains here, no valleys, only clouds, storms and currents, endless weather, dancing under the gravity of a world that does not sleep. And at the centre of this constant chaos is the great red spot, a storm larger than Earth, spinning for centuries. Its rusty hue, its oval shape, its churning presence. It is the solar system's most famous cyclone, a high-pressure system that has endured since at least the 1600s, when early telescopes first glimpsed it. We do not know exactly how it formed. We do not know when, or even if, it will fade. But we do know it is ancient, persistent, and oddly serene, when viewed from a distance. A quiet eye in a planet of whirlwinds. Beneath those clouds lies mystery. Jupiter has no solid surface. The further you descend, the thicker the atmosphere becomes, pressure rising, temperatures climbing, until gas compresses into liquid, and then perhaps into a sea of metallic hydrogen, where electrons move freely and strange magnetic forces arise. At its core may lie a rocky seed, or not, we're still not sure. The deeper you go, the harder it is to define what is planet and what is simply depth. But Jupiter's influence isn't confined to itself. It has a magnetic field that is 20,000 times stronger than Earth's, a field so vast that it creates radiation belts that would fry most spacecraft if not properly shielded. A field that stretches across millions of kilometres, interacting with the solar wind, its moons, and even the vacuum of space in which it drifts. And that magnetic field does something beautiful. It creates auroras, not just on Earth, but on Jupiter too. Gigantic auroras dance around the poles of the gas giant, visible in ultraviolet, shimmering in response to the electric connections it shares with its moons. Ah, the moons. Jupiter has dozens, but some are more than rocks, some are worlds. Io, for instance, is a place of fire. It is the most volcanically active object in the solar system, its surface constantly reshaped by eruptions. Tidal forces from Jupiter stretch and compress it, turning its insides molten, causing volcanoes to spew sulphur high into a tenuous sky. Io is not peaceful. It is in turmoil, and yet its violence is predictable, a constant ballet of stress and release. Then there's Europa, quiet and pale, a moon encased in a shell of ice. Beneath that ice, we believe, is a liquid ocean, more water than all the oceans on Earth combined. That ocean is kept warm not by sunlight, but by the same tidal forces that torment Io. Jupiter squeezes Europa gently, rhythmically, and that squeezing creates heat, enough, perhaps, to keep the water below from freezing. Some even suspect that life may exist there, far beneath the surface where no light reaches but warmth still flows. If life does exist beyond Earth, Europa may be one of the first places we find it, and while Jupiter inspires us with its mystery and scale, it also protects us in a quiet, uncelebrated way. Its gravity is so strong that it acts as a kind of cosmic shield, pulling in or flinging away asteroids and comets that might otherwise threaten Earth. Jupiter's presence helps stabilise the inner solar system, cleaning up the paths of rogue objects like a watchful shepherd guiding a flock. It doesn't catch everything, but without it, Earth might have faced far more frequent catastrophic impacts. There is something noble about that. Jupiter doesn't just dominate, it guards. Not through aggression, but through presence. Its mass matters, its orbit matters, its long, slow dance around the Sun, once every 12 Earth years, helps choreograph the movements of things we cannot see and rarely think about. And while it doesn't know we're here, its gravity has helped keep this fragile world safe for billions of years. So tonight, if your thoughts drift toward Jupiter, let them do so slowly. Picture a planet without a surface, yet filled with substance. Imagine storms that have lasted longer than our countries, magnetic fields that light up the void, and moons that contain fire and oceans in the same breath. Let yourself feel small, but not insignificant, because even small things, like us, can notice greatness and whisper thanks to giants that do not hear. And if you fall asleep with Jupiter in your thoughts, know this. You are dreaming beneath the watch of a planet that spins in silence, shepherding comets and shaping light, swirling endlessly without ever once being still. Saturn has always felt like a planet drawn from myth, a world so perfectly adorned, so visually striking, that it seems less like something real and more like something imagined. Even through a modest telescope, those rings appear with a clarity that feels almost absurd. Crisp arcs of pale gold floating around a gentle banded sphere. It is a sight that has stirred wonder for centuries. But Saturn is not merely beautiful, it is strange, improbable, and full of quiet riddles that defy simple explanation. Begin with its density. If you were to imagine a bathtub large enough to hold it, a ridiculous image, and yet somehow pleasing, Saturn would float. It is the only planet in the solar system with an average density lower than water. That fact feels whimsical, but it also hints at what Saturn really is. A massive ball of gas made mostly of hydrogen and helium, with no solid surface to stand on, and a deep cloud-shrouded interior that presses inward under the weight of its own immensity. And then there are the rings, thin, dazzling, and yet vast beyond comprehension. They're composed mostly of ice particles, with some dust and rocky debris, spread out in layers that stretch for hundreds of thousands of kilometres but remain only tens of metres thick. They are as delicate as they are enormous. From afar they look like a solid band. Up close, they are billions of tiny worlds orbiting together, some the size of boulders, others no bigger than grains of sand. For a long time, scientists thought the rings might be as old as the planet itself. But recent research suggests they may be younger than the dinosaurs, formed perhaps only 100 million years ago, a blink in cosmic time. They might be the remains of a shattered moon, or the captured remnants of a passing icy body torn apart by Saturn's gravity. And they may not last. Saturn's rings are slowly raining down onto the planet, a shimmering, invisible drizzle of particles pulled by gravity and magnetism into the upper atmosphere. In a few 100 million years, the rings may be gone altogether. What we see now is a temporary grace, a planetary adornment caught mid-fall. If the rings are Saturn's most famous feature, then its hexagon is surely the most puzzling. At the planet's north pole, there exists a massive jet stream shaped like a perfect six-sided polygon. It's not an optical illusion or a cloud pattern. It's an actual persistent atmospheric structure, thousands of kilometers across, that circles the pole like a geometric crown. No other planet shows anything quite like it. Scientists have recreated similar shapes in rotating fluids in laboratory settings, but the sheer stability and scale of Saturn's hexagon remain mysterious. It has lasted for decades, possibly centuries, locked in place, swirling and unmoving like some celestial sigil carved into the clouds. And Saturn's moons, they deserve stories of their own. Over 140 confirmed so far, each with its own character, its own history. But two of them stand out like poetry whispered into deep space. First, Titan, Saturn's largest moon, and the second largest moon in the solar system. Titan is a world with a thick atmosphere, richer and more complex than any other moon. It is shrouded in orange haze, and on its surface, lakes, rivers and rain sculpt the land. But these lakes are not made of water. They are filled with liquid methane and ethane, hydrocarbons that would be gas on Earth, but flow like water in Titan's frigid environment. Titan has seasons, weather, and perhaps even cryovolcanoes. Volcanoes that erupt icy slurries instead of molten rock. It is alien, and yet eerily familiar. A place where rain falls onto soil-like plains and slowly shapes a world no one has walked. Then there's Enceladus, a small bright moon that should have been unremarkable, but turned out to be one of the most astonishing discoveries of modern planetary science. Beneath its icy crust lies a liquid ocean, and from cracks near its south pole, geysers of water vapour and organic molecules erupt into space. These plumes have been sampled by spacecraft, and their composition suggests that Enceladus may have all the ingredients necessary for life. It's a tiny moon, only about 500 kilometres across, but within it, the potential for an entire ecosystem may slosh in darkness, warmed by tidal forces from Saturn's gravity. There is something deeply calming and deeply humbling about Saturn and its domain. It's a planet of beauty, but not simplicity. Its rings are fragile. Its atmosphere hides puzzles. Its moons whisper possibilities. And through it all, it turns slowly, once every 10.5 Earth hours, its massive form spinning like a top in the black. When you imagine Saturn now, don't just see the golden rings. Picture the hexagon, silent and strange. Picture Titan's methane rain falling on a shore no human has seen. Picture Enceladus sending its ocean into space, molecule by molecule. Picture the invisible rain of the rings, falling slowly toward a planet that will outlast it. And let that image hold you, like Saturn itself, in orbit, gently, quietly, permanently in motion, and yet somehow always at rest. Some planets announce themselves with noise, with spectacle, with storms the size of continents or rings that gleam like sharpened halos. But Uranus does none of that. It doesn't roar or spin wildly or boast colours that catch the eye. Instead, it drifts quietly, slowly, tilted so far it seems more asleep than awake. If the solar system were a classroom, Uranus would be the students slouched so far in their seat that they look like they've given up. But in fact, they're paying more attention than anyone else. They're just doing it sideways. And sideways is no exaggeration. Uranus is tilted at 98 degrees, meaning it essentially rolls along its orbit like a barrel. Its poles lie where most planets have their equators. Imagine spinning a basketball on your finger. Now tip it nearly all the way until it spins around the edge, like a wheel instead of a top. That's Uranus. Its seasons are the most extreme in the solar system, not because of temperature changes, it's cold all the time, but because for decades at a time one hemisphere basks in sunlight while the other lies in continuous darkness. Why is it like this? The most likely explanation is that Uranus was struck long ago by something huge. Perhaps another protoplanet, a glancing collision that didn't shatter it but nudged it off kilter forever. There's no way to prove it directly, but the evidence is compelling. Its odd tilt, its magnetic field that's wildly offset from the centre, and the way its rings and moons seem twisted into its side all point to a traumatic event in its distant past. A cosmic nudge that rewrote its story. Despite this dramatic history, Uranus is often called the quietest of the gas giants. Its atmosphere is pale, a soft aquamarine blue tinged with a touch of green, a colour caused by methane gas, which absorbs red light and reflects blue. But unlike Jupiter and Saturn, which wear their turbulence like layered ribbons, Uranus looks smooth, almost featureless. It hides its storms. For a long time, scientists thought it had no weather worth noting, but with better instruments, especially from the Hubble Space Telescope and Earth-based observatories using infrared, we've come to learn that Uranus does have storms. They're just subtle, deep, hidden under layers of gas and haze moving slowly in the dim light. And it's cold. Colder than any other planet in the solar system. Colder even than Neptune, which lies farther from the Sun. The reason isn't fully understood. Perhaps Uranus doesn't have a strong internal heat source. Perhaps it lost energy long ago, maybe during the impact that tilted it. Whatever the cause, temperatures in its upper atmosphere drop as low as minus 224 degrees Celsius. It's a world where warmth is not just rare, it's almost forbidden. Yet even here, in this tilted, frigid hush, there is structure. Uranus has rings, though they're much darker and narrower than Saturn's. They weren't even discovered until 1977. Made mostly of larger particles rather than fine dust, these rings are like charcoal strokes on a sky drawn in watercolour. There are at least 13 known rings, some bright enough to reflect radar signals, others so faint they seem more like whispers of past collisions or formations, and surrounding them, moving through this sideways ballet, are 27 moons, each named after characters from Shakespeare and Alexander Pope. Oberon, Titania, Miranda, Ariel and Umbriel, poetic names for silent companions circling a quiet world. Some of these moons are more than just ice balls. Miranda, for instance, looks as though it's been shattered and reassembled, its surface covered in mismatched terrains and cliffs towering 20 kilometres high. One hypothesis suggests it suffered a massive impact and came back together imperfectly, like a puzzle forced into place after being broken. And then there's the possibility that beneath the cold and quiet, oceans may still exist. Not of water in the traditional sense, but briny, slushy layers deep beneath the icy crusts of the moons, and perhaps even within Uranus itself. These would not be oceans we could swim in, but they might be able to conduct electricity, generate magnetic effects, and provide just enough thermal energy to stir chemistry. The kind of chemistry we look for when we dream of life in unlikely places. But we don't know much more because we've only visited Uranus once. Voyager 2 passed by in 1986, collecting images and data as it coasted past at nearly 15 kilometres per second. It gave us our first close look, but no orbit, no landers, no return trips. Since then, we've watched from afar, waiting, guessing, listening for changes in light and spectrum that might tell us what this planet is whispering. And perhaps that's part of its magic. Uranus is not a planet of bold declarations. It is not a headline maker, but in its tilt, in its chill, in its slow and thoughtful drift around the Sun, once every 84 Earth years, it reminds us that the solar system is not just a stage for grand drama. Sometimes it's a place for quiet strangeness, for puzzles that refuse to solve themselves too easily, for worlds that don't perform but simply are. Tonight, as your thoughts begin to soften, let yourself drift sideways for a while, like Uranus, turn just enough to change your view. Imagine a pale blue sphere rolling gently through a dark corridor of space, its moons trailing behind like pages in a forgotten book. Imagine silence, not as absence, but as presence. Cold, soft, deep, and filled with unanswered questions. And if your dreams tilt slightly as you fall asleep, don't worry. The sky is full of sideways wanderers. If Uranus is the quiet, sideways dreamer of the solar system, then Neptune is the deep sleeper, the one wrapped in soft blue and darker still, distant and slow and full of secrets carried by winds no one hears. It lies at the edge of what we once considered the planetary boundary, the eighth and final world from the sun, spinning in a realm where sunlight arrives like a whisper, faint, diluted, and cold. And yet, in this frozen place, Neptune holds one of the most violent atmospheres ever observed. The planet's colour is the first thing that captures you, a deeper blue than Uranus, almost cobalt, rich and luminous. That striking hue is also caused by methane in its atmosphere, which filters red light and reflects blue. But there may be more to the colour than we understand. Perhaps a mystery ingredient, a subtle difference in cloud structures or haze, like a painting mixed with one unknown pigment that no one has yet identified. Beneath this beauty, however, Neptune's winds roar silently. While Earth's fiercest storms might reach 300 kilometers per hour, Neptune's can exceed 2,000 kilometers per hour, the fastest winds in the solar system. And yet, because the atmosphere is so thin and cold, these storms likely pass without the kind of drama we imagine. There's no thunder, no rain, no flashes of lightning that we know of, just movement, persistent, invisible motion, swirls of methane clouds turning around a pale core, like dancers spinning through the farthest ballroom of the sun, and no one knows why they're so fast. Neptune is far from the sun, receiving little energy. Its internal heat source, some remnant of its formation, must still be active, stirring the gases from within. It radiates more energy than it receives. The result is a world where the weather is not solar-driven, but born of the planet's own internal breath. Back in 1989, Voyager 2 became the first and only spacecraft to visit Neptune. In a brief flyby, it captured images of a massive dark storm near the equator, dubbed the Great Dark Spot. Similar in size to Earth, it resembled Jupiter's Great Red Spot in form, though not in behaviour. When the Hubble Space Telescope looked again a few years later, the storm had vanished. Since then, other dark spots have appeared and disappeared like temporary bruises in a world of swirling silence. These storms seem to form and dissolve without warning, perhaps from internal heat rising suddenly, perhaps from deeper mechanisms we don't yet understand. Neptune has rings, too, thin, dark arcs that seem incomplete. Some of them are clumpy and uneven, like a necklace with missing beads. Others fade into near invisibility, and while they lack the grandeur of Saturn's, their presence suggests something ancient, that even here, where everything is slow and cold, collisions and formations continue, quietly, gradually, like ice forming on the surface of a still lake. And then there is Triton, Neptune's largest moon, and one of the most unusual in the entire solar system. Unlike most large moons, Triton orbits backward, in a direction opposite to Neptune's rotation, a retrograde motion that strongly suggests it was captured, not formed in place. Perhaps it was once a dwarf planet, drifting through the Kuiper belt until Neptune's gravity drew it in and made it part of its world. But the result is a tension, an orbit that spirals slowly inward, pulling Triton ever closer. One day, in the distant future, it may be torn apart by tidal forces, its remains spreading into a ring. For now, Triton remains intact and active. Voyager 2 revealed a surface with few craters, but many strange textures. Cantaloupe-like terrain, smooth plains, and most stunningly, geysers erupting from its surface. These geysers are powered not by heat from the sun, but by internal warmth, perhaps the slow flexing of Triton's icy crust due to tidal stresses. The plumes rise into a thin nitrogen atmosphere and then fall back, gently frosting the surface with new ice. Triton is not dead. It breathes in its own cold, periodic way. If Europa and Enceladus are moons that might harbour oceans beneath their shells, then Triton deserves a place in the same conversation. Its retrograde orbit, its geological activity, its dynamic surface. They all hint at a world with inner life, not in the biological sense perhaps, but certainly in motion and story. Neptune completes its orbit around the Sun once every 165 Earth years. That means since its discovery in 1846, it has only just completed one full trip. Imagine that. A planet so distant and deliberate that a single year takes longer than a human lifetime. Neptune is not in a hurry. It drifts, it rotates every 16 hours, and it keeps its secrets. Not jealously, but quietly, as if it knows that not everything needs to be known quickly, that some things are meant to be wondered at from afar. So let your thoughts drift with it. Imagine a world of sapphire clouds and invisible wind, of storms that come and go like passing moods. Imagine Triton spinning backward under a pale sky, sending up geysers of nitrogen into an atmosphere made of soft frost. Imagine the edge of the known planets not as a wall, but as a whisper, a slow turning, a waiting place, where time moves at its own pace. And as you breathe slower, let the idea of Neptune settle over you like dusk. Cold, yes, but not empty. Distant, yes, but not lifeless. A planet that sings in silence and teaches us that not all motion needs noise. Some of it, the most profound perhaps, is made of wind no one hears and storms that vanish before we know they were even there. When we think of moons, we often imagine them as simple companions, orbiting planets like quiet satellites, passively reflecting sunlight, dry and barren and unchanging. Our own moon reinforces that image. A familiar grey face, worn smooth by ancient impacts, always turning the same side toward us. But not all moons fit that mould. In the darker corners of the solar system, there are moons that rival planets in size, complexity and strangeness. Some have magnetic fields, some have atmospheres, some have oceans beneath their skin. And if they orbited the Sun directly, rather than their parent planets, we might not call them moons at all. We might call them worlds. Start with Ganymede, the largest moon in the solar system. Bigger than Mercury, nearly 3/4 the size of Mars, Ganymede orbits Jupiter in a slow, steady rhythm wrapped in ice and rock. It is the only moon we know of that has a magnetic field, a telltale sign of internal motion. Beneath its frozen crust, a liquid iron core churns, creating a magnetic field strong enough to carve out its own miniature magnetosphere inside Jupiter's vast one. That's something even Mercury can't manage, and between the crust and the core, scientists believe there's a salty ocean, perhaps 100 kilometres deep, locked beneath ice, warmed by tidal forces and radioactive decay, a hidden sea beneath a silent sky. Next to Ganymede, another of Jupiter's moons, Callisto, might seem less dramatic. It's an old world, possibly the oldest surface in the solar system, judging by the sheer number of craters that pockmark its face. Unlike Europa or Io, Callisto shows few signs of internal activity, but that quiet may be misleading. Some evidence suggests it too harbours a subsurface ocean, isolated beneath a crust frozen for billions of years, a dark, cratered shell above, a possible sanctuary of liquid water below. If Ganymede is a giant with a molten heart, then Callisto is a hermit, ancient, patient, undisturbed, and perhaps still holding secrets in its deep. Then there is Titan, Saturn's largest moon, and the only moon in the solar system with a thick atmosphere. Its orange haze hides a surface that, while alien, feels uncannily familiar. Rivers and lakes etch its icy plains. Rain falls from clouds. Shorelines shift with seasons, but the temperatures are far too low for liquid water. Instead, the lakes are made of liquid methane and ethane, and the rain that falls from the sky is hydrocarbon drizzle. A different chemistry, but a similar process. Erosion, flow, weather. Titan has seasons, winds, and maybe even cryovolcanoes that release water-ammonia mixtures rather than molten rock. And beneath all of that, Titan is believed to hold yet another liquid ocean. A vast one, possibly, bigger than Earth's, sandwiched between icy crust and rocky core. That makes Titan a layered world. Air, surface, sea, rock. An atmosphere thick enough to fly through with wings attached to your arms. A climate system sculpted not by warmth, but by cold chemistry. If Earth weren't what it is, if our blue planet had never formed, Titan could have been the one to capture our imagination. A planet-like moon where alien weather falls on alien lakes under an orange twilight that never quite becomes day. Even Enceladus, though smaller than Ganymede or Titan, carries planetary significance. We spoke of it before. A moon of Saturn only about 500 kilometers across, but alive in ways we never expected. From the tiger-striped cracks near its south pole, plumes of water vapor erupt into space. These geysers are evidence of an underground liquid ocean, kept warm by the flexing tides of Saturn's gravity. The plumes contain water, organic molecules, and hints of hydrothermal activity at the seafloor, a potential cradle for life, if the conditions are right. Enceladus doesn't just hint at a story, it tells one every time it exhales another breath of sea into the void. Together these moons challenge the way we define a planet. They orbit planets, but behave like planets themselves. Some have atmospheres, some have oceans, some have geology, weather, magnetism. They are diverse, they are dynamic, and crucially, they may be better places to look for life than many of the planets we've already studied. Mars may have had water once. Venus may have once been mild, but Titan, Europa, Enceladus, Ganymede. These places have liquid water now, hidden beneath their surfaces, shielded from radiation, stirred by heat and chemistry. This is one of the quiet revolutions of planetary science. The idea that life might not need surface oceans or temperate sunlight, that it might thrive in darkness beneath kilometers of ice, formed not by stars but by tidal friction and radioactive decay. Life that never sees the sky, never feels wind, never hears sound, and yet exists. Not just as possibility, but perhaps already as fact. We don't know, but that's what makes these moons so compelling. They're not just moons. They're reminders that we haven't looked everywhere, that the solar system is deeper than it appears, that the things circling the giants might be themselves the most promising places to find something more than silence. So tonight, as you drift further from the centre of the system, let your thoughts settle on these hidden worlds. Let your imagination descend through layers of ice into dark oceans stirred by ancient tides. Let Titan's lakes ripple in methane wind. Let Ganymede's core hum with magnetic song. Let Enceladus whisper steam into space again and again, like a world trying to get your attention. And maybe, in the stillness, you'll hear them. Beyond the planets and their strange, shimmering moons, the solar system continues, not with empty space, but with a long and widening stretch of mystery. Out here, the sun is no longer a blazing centre, but a distant star, barely more than a bright dot against the black. Temperatures drop to near absolute zero, and the silence becomes heavier. But still worlds remain. Small worlds, cold worlds, forgotten, distant, and yet quietly remarkable. At the centre of this outer collection is Pluto, a name that evokes childhood science lessons, debates, demotions, and nostalgia. Once the 9th planet, now known as a dwarf planet, Pluto has never stopped being fascinating. For decades, it was just a blurry point of light in telescopes, its true nature obscured by distance. But in 2015, NASA's New Horizons spacecraft flew past Pluto for the first time, transforming a mysterious speck into a place. And what it found was astonishing. Pluto has mountains made of water ice, towering like frozen granite in a land too cold for liquid water. It has a vast heart-shaped glacier called Sputnik Planitia, made of nitrogen ice that slowly flows and shifts, a slow-motion dance of molecules over millions of years. It has misty blue skies, delicate hazes that rise in layers above the surface, scattering sunlight in ways we didn't expect. And perhaps most surprising of all, Pluto is still geologically active. It should be frozen, static, asleep, but it isn't. Beneath the surface, warmth lingers, perhaps from radioactive elements, perhaps from a subsurface ocean, insulated by layers of exotic ice. Even here, at the edge of light, movement endures. But Pluto isn't alone. It's part of a broader family, the Kuiper Belt, a wide band of icy bodies that stretches beyond Neptune's orbit, filled with remnants of the early solar system. Like a cosmic attic, the Kuiper Belt holds on to what the larger planets didn't consume. Small, icy, irregular worlds that whisper of beginnings. Among them are names that sound like myth and whisper like wind. Makemake, Haumea, Eris. Each one a dwarf planet in its own right. Each one orbiting the sun on paths that are wide, tilted, elongated. Journeys that take centuries. Haumea spins so quickly that it's stretched into an ellipsoid, shaped more like a rugby ball than a sphere. It has a thin ring, possibly formed from a past impact. Eris, slightly smaller than Pluto but more massive, was the catalyst for the very debate that led to Pluto's reclassification. And Makemake, with its methane ice surface, reflects sunlight in shimmering patterns, though it too remains barely explored. These are not vibrant places, not in the way we think of Earth or even Mars. They are frozen relics, time capsules from when the solar system was young. But that doesn't make them simple. Their surfaces hold records of impact, erosion, chemistry. Their orbits suggest interactions long ago with giant planets, and their very survival in such thin light and fragile balance is a kind of quiet persistence. Beyond the Kuiper Belt lies a region that isn't even seen, only theorized. The Oort cloud, a vast spherical shell of icy debris surrounding the entire solar system, possibly stretching a light year from the Sun. No spacecraft has ever visited it. No telescope has ever imaged it directly. But we infer its presence from the long-period comets that occasionally fall toward the Sun on paths so wide, so strange, they must have come from this unseen border. The Oort cloud, if it exists as predicted, is the last whisper of the solar system, a cloud of beginnings so distant its members may orbit the Sun only once every few million years. A comet born there might spend most of its life in frozen darkness, only to streak across Earth's sky for a few brief days, shedding a luminous tail and vanishing again into silence. These comets carry not just water and rock, but organic molecules, the building blocks of life. They may have helped seed Earth with the ingredients for biology. They may carry the history of the Sun's birth and of the stars that came before it. And farther still, though we don't know for sure, there may be something large. Astronomers have found hints, gravitational nudges in the orbits of distant Kuiper Belt objects that suggest the presence of a ninth planet, not Pluto, something much farther, much larger. It has not yet been seen. We don't know if it exists, but we've given it a name, Planet 9, a ghostly mathematical presence far beyond the reach of our current instruments, shaping the edge of the system with invisible hands. Whether or not Planet 9 is real, the idea itself is a mirror, showing us how much we still don't know. The solar system is not a solved puzzle. It is a living system, growing, evolving, and still full of places we have not visited and stories we have not yet learned to read. So as you lie in bed tonight, let your thoughts drift beyond the planets, past Neptune, past Pluto. Let them wander into the cold, dim corridors where Makemake spins in silence, where Eris loops through darkness, where long-forgotten comets await their moment in the sun. Picture the Oort cloud, not as a place, but as a fog of memory, a border of possibility. And if you find yourself imagining what might lie even farther, know that you're not alone. We're still looking, still guessing, still listening for echoes from a frontier where the map fades into mystery and where science ends in starlight. You might think that weather needs air, that storms can't form unless there's a sky like ours, rich with oxygen and nitrogen, with clouds drifting gently above forests and oceans. But weather, it turns out, doesn't care about our expectations. In the solar system, wind blows where no one hears it. Lightning crackles in clouds that smell of sulfur or methane. Rain falls in droplets no one could stand beneath. And sometimes the fiercest storm begins in a place where there's barely any atmosphere at all. Take Mars, for instance. Its atmosphere is whisper thin, made mostly of carbon dioxide, with only about 1% the pressure of Earth's. If you stood on the Martian surface without a suit, your breath would vanish into the cold, and your skin would lose moisture in seconds. And yet, even here, there is weather. The kind of weather that paints the ground and dims the sky. Dust storms sweep across the plains, not with the roar of wind, but with a hush. Fine particles lifted into the sky by convection and breeze. Some of these storms grow large enough to engulf the entire planet, shrouding Mars in a swirling amber haze for weeks. They are not loud, but they are powerful, a world's quiet exhalation that reshapes its face. Over on Venus, the story is very different. The atmosphere is so thick, so heavy, that walking through it would feel like moving underwater. The pressure at the surface is enough to crush a submarine. The clouds are made not of water, but of sulfuric acid, drifting in yellow layers across a furnace-hot sky. Lightning has been detected here too, crackling through the dense clouds. Although scientists still debate how common or intense these strikes are. But the sky is alive. Winds whip around the planet at speeds far faster than the surface rotates, creating a phenomenon called superrotation, where the clouds lap the planet every 4 Earth days. It's as if the atmosphere itself can't bear to move slowly, even though the surface turns with painful lethargy. And then there is Jupiter, where lightning flashes light up the deepest clouds and storms spiral for centuries. Its atmosphere, made mostly of hydrogen and helium, doesn't have a surface to land on, but it does have layers upon layers of motion. Scientists have detected lightning here that's many times more energetic than anything on Earth, striking through clouds of water and ammonia hidden in the depths. These storms don't roll across continents. They churn inside a planet that has no edge, a world of continuous sky, where thunder belongs to no land. We often imagine lightning as a sound, but in most of these places there is no sound, at least not in the way we would hear it. On Mars, for example, sound travels more slowly and is absorbed more easily. A clap of thunder there would be a dull, stretched-out sigh, if you could hear it at all. In space, there is no medium to carry the sound, only the flicker of light and the memory of a spark. Weather happens, but silently. And the rain. Oh, the rain. On Earth, it falls as water, nurturing life, feeding rivers, pooling into oceans. But on other worlds, rain tells stranger stories. On Venus, it rains sulfuric acid. The droplets begin high in the clouds, condense into acid rain, and then, just before they reach the ground, they evaporate in the searing heat, never touching the surface. It's a ghost. Rain, a cycle that ends in vapour before it ever begins to fall. On Titan, Saturn's great moon, it rains liquid methane. There, the atmosphere is thick and cold, and methane plays the role water does on Earth. Clouds gather, drizzle falls, rivers form, lakes ripple. It's all familiar, and yet fundamentally different. The same process painted in new chemistry. On Neptune and Uranus, under immense pressure deep within their atmospheres, scientists believe carbon atoms may compress into diamonds, and those diamonds may rain down through the clouds, sinking slowly, maybe melting under pressure, maybe accumulating at the core. Imagine a place where the sky glitters from within, and solid gemstones fall like hail through layers of ice and gas, rain, wind, storms, lightning. Each of these exists in forms we can barely imagine. And not just where there's air. Even on worlds without traditional atmospheres, there are echoes of motion. Take Io, Jupiter's volcanic moon. Its surface is constantly reshaped by eruptions, geysers of sulfur and rock exploding into space, forming plumes hundreds of kilometers high. These are not weather exactly, but they are still atmospheric events, driven by tidal forces and heat. For a few brief minutes, an eruption creates a temporary sky, a breath exhaled from deep within the moon. Weather, we are learning, is not just a matter of air pressure and humidity. It is a form of planetary expression, the visible moving consequence of heat, chemistry, motion, and time. It can be as thin as the Martian breeze or as crushing as Venus's sky. It can fall as rain, glow as lightning, drift as haze, or even strike in silence across a gas giant's endless dusk. Tonight, if you hear wind outside your window, let your mind drift to stranger winds. Winds that leave no footprints, storms that never roar, rains that never land. Imagine a slow gust moving through the canyons of Mars. Picture acid droplets vaporizing mid-fall. Picture methane storms darkening Titan's orange sky. Picture diamonds falling through invisible air. And remember that the weather we know is just one version, a familiar verse in a much longer poem being written, quietly, across 100 skies we've only just begun to understand. There are lights in the sky that move with no sound, no source, no fire. Curtains of green, purple and red that drift and shimmer in silence, dancing not from heat, but from particles. They come from the meeting of wind and magnetism, from the collision of the sun's breath with the Earth's invisible shield. They are auroras, and they remind us that even in stillness the universe is alive with motion. On Earth, we call them the aurora borealis in the north and aurora australis in the south, names rooted in dawn and direction, but their origin is far more cosmic. They begin with the solar wind, a stream of charged particles constantly flowing from the sun flung across the solar system like invisible sparks. Most of the time, these particles pass by us unnoticed, absorbed into the heliosphere or deflected by planetary magnetic fields. But sometimes they collide with those fields, and the sky glows in response. Our planet is wrapped in a magnetosphere, a magnetic shield generated by molten iron spinning in Earth's core. This shield extends far into space, deflecting harmful solar radiation and protecting our atmosphere from being stripped away. Where it dips closest to the planet, near the poles, some solar particles slip through. As they enter the upper atmosphere, they interact with oxygen and nitrogen atoms, exciting them, causing them to release light. The result is a glow that flickers and flows, shaped by Earth's magnetic lines like wind brushing across a field of tall grass. These auroras aren't just beautiful. They're a sign of planetary health, evidence that our magnetic field is working, guarding us from a universe filled with radiation. They're also quiet. Despite their electric origins, they make no sound. You can stand under a brilliant dancing sky and hear nothing but your own breath. A reminder that even the most dramatic cosmic performances are sometimes staged in silence. And Earth is not alone in this light show. Jupiter, with its immense magnetic field, 20,000 times stronger than Earth's, produces gigantic auroras around its poles. These auroras are constant, not just occasional bursts, because Jupiter's magnetic field is so strong and its interaction with the solar wind so dynamic. They glow in ultraviolet, mostly invisible to the naked eye, but breathtaking when captured by spacecraft and specialized telescopes. What's more, some of Jupiter's auroras are powered not just by the sun, but by its moons. Io, the volcanic satellite we spoke of earlier, releases charged particles into Jupiter's magnetic field, fueling light shows more complex than anything we see on Earth. Saturn too wears auroras, delicate ovals of light that pulse and ripple in the planet's layered sky. Observed by the Cassini spacecraft, Saturn's auroras are influenced by solar wind, but also by seasonal changes in the planet's tilt. Their glow, faint and variable, serves as another example of how magnetic fields shape the quiet theatre of the solar system. But not every world is so fortunate. Mars, for instance, has no global magnetic field. It once did, billions of years ago, but that field faded as the planet's core cooled. Today only remnants remained, weak local fields locked into crustal rock. As a result, Mars is exposed. The solar wind, no longer deflected, has eroded its atmosphere over time, stripping it away molecule by molecule. That's one of the reasons Mars is so dry, so airless. Without a magnetic shield, the planet's surface is left vulnerable to space itself. Venus, though similar in size to Earth, also lacks a strong magnetic field. And yet it still holds a thick atmosphere, possibly because of its dense clouds and slow rotation, which create other forms of atmospheric protection. Still, it too is constantly sculpted by solar wind, its upper atmosphere flowing like a long trailing veil away from the sun. This contrast between worlds that hold their breath and those that cannot tells us how important magnetic fields are. They're not something we see, not something we feel, but without them, planets lose more than just their weather. They lose their voice, the ability to respond, to shimmer, to reflect the sun's energy in light rather than in loss. And then there's space weather, the quiet force behind it all. Solar flares, coronal mass ejections, the shifting mood of our star. These events send bursts of particles hurtling through the solar system. When they hit Earth, they can enhance auroras, disrupt satellites, even interfere with radio signals and power grids. But they are also a reminder. We're connected to the sun, not just by gravity and light, but by electricity, magnetism, breath. We live in a system of relationships where the sun breathes and the planets reply, sometimes with storms, sometimes with silence, and sometimes with light. So tonight, if you imagine the night sky above you, let your thoughts slip past the clouds and into the invisible architecture of our world. Picture the magnetic field, a dome of protection shaped by molten iron deep below your feet. Picture solar wind brushing against it, like fingers across a harp. Picture the sky answering not in words but in colours. Green ribbons, purple waves, red flares that ripple and fade. Picture Jupiter glowing from within, Saturn's poles flickering like candlelight, Mars left open to the void. And as you drift into sleep, feel thankful, not just for the light, but for the shield that allows you to see it, for the quiet guardians that shape the storms, for the wind that glows but never burns. Time, like weather, behaves differently depending on where you are. It bends and stretches, not in the relativistic way that Einstein described, but in the rhythms of daylight and darkness, in the length of a planet's spin, in the arc of its seasons. On Earth, we take our 24-hour days and 365-day years for granted. They feel balanced, stable, and reassuring. But elsewhere in the solar system, the clock runs to strange rules. Days last longer than years, seasons are slow and uneven, and sometimes a night can last decades. Start with Venus, Earth's nearest planetary neighbour, and one of the strangest clocks in the solar system. It rotates incredibly slowly, so slowly in fact, that a single Venusian day is longer than a Venusian year. It takes about 243 Earth days for Venus to complete one rotation on its axis, but only 225 Earth days to orbit the Sun. To make matters more peculiar, it spins backward in what's called retrograde rotation, meaning the Sun would rise in the west and set in the east. if you could ever see it through the thick clouds of sulfuric acid. The combination of a slow spin and dense atmosphere makes for an environment where weather isn't in a hurry. The winds in the upper atmosphere are fast, racing around the planet in just a few Earth days. But down on the surface, the pace is glacial. The air is thick, the pressure crushing, and temperatures are hot enough to melt lead. Yet everything feels still, stretched out over time, as if Venus is perpetually waiting for something that never arrives. Contrast that with Jupiter, the largest planet in the solar system, which spins with astonishing speed. A day on Jupiter lasts just under 10 Earth hours. Despite being more than 1,300 times the volume of Earth, it rotates so quickly that its shape is visibly squashed, bulging at the equator, flattened at the poles. This rapid spin fuels Jupiter's dynamic atmosphere, creating powerful jet streams and storms that last not hours or days, but centuries. The Great Red Spot, for instance, has been raging for at least 350 years, perhaps longer, a storm so vast that Earth would fit inside it. Here, weather doesn't come and go with the day. It becomes part of the planet's identity, embedded in its atmosphere for generations. And then there's Uranus, the sideways planet. With its 98-degree tilt, Uranus doesn't just have seasons, it has extreme ones. Each pole spends 42 Earth years in continuous sunlight, followed by 42 years of a night. Imagine living through a winter that lasts a human lifetime, and then watching the sun rise for the first time in decades. The changes aren't fast, but they are profound. During these long seasons, the temperature doesn't fluctuate wildly. Uranus is uniformly cold. But the distribution of sunlight changes how storms form and move. When Voyager 2 flew past in 1986, Uranus looked calm, almost featureless. But as seasons shifted, the planet became more active, revealing storms that had once been hidden beneath its blue haze. Even the moons of the outer planets experienced strange cycles of time. Titan, for instance, has seasons like Earth, because Saturn is tilted similarly. But its year lasts 29.5 Earth years, so each season stretches for more than 7 Earth years. As Titan tilts toward or away from the Sun, methane rains fall more frequently in one hemisphere than the other, lakes fill and evaporate, and the haze above thickens or thins. On a moon where temperatures hover around minus 180 degrees Celsius, even the slowest changes carry meaning. Other moons, like Europa or Enceladus, may not have weather in the conventional sense, but they still have cyclical behaviours. Tidal forces from their parent planets create rhythms of heating and flexing that can drive geysers, crack ice, and stir hidden oceans. These aren't seasonal in the way we experience them, but they are temporal. Patterns that repeat, expand, and influence the landscape over time. When we look at the planets and moons of our solar system, what we see is a kind of temporal diversity. Some places live fast, spinning quickly, changing constantly. Others live slow, with years that feel like centuries and days that stretch beyond a human life. Some worlds breathe in storms that last generations. Others freeze in seasons that linger longer than memory. Time on other worlds is a reminder that our clocks are local, that our definitions of a day or a year are just measurements of motion, not constants. That elsewhere people, if there were people, might measure their lives not in days and weeks, but in sunrises that take a decade, in storms that pass slowly like dreams, in winters that hold a planet in their arms for half a century. And then there's the idea of weather as memory. A storm that outlives those who saw it form, a season that shapes the surface long after it ends. Time and weather entwined, repeating but never identical, flowing through atmospheres like the breath of planets. So tonight, as your own day winds down, let your mind wander through these alien clocks. Let yourself imagine what it would be like to wake beneath a sky that hasn't seen sunlight in 40 years, or to stand under a storm that began before your great-grandparents were born. Let the slow seasons of Titan pass across your thoughts. Let Jupiter's spinning shadow rush past your dreams. Let Uranus roll through another silent night. And as you close your eyes, remember, time moves differently in every corner of the cosmos. But no matter how fast or slow, it is always carrying something forward. A breeze, a season, a moment, a thought. And tonight, it carries you. The solar system, vast as it is, does not fly apart. The planets do not drift into chaos, and the comets do not vanish into the abyss without return. Moons stay near their worlds, and asteroids follow paths that were carved before any eye ever saw them. Somehow, in all this vastness, there is structure, order, rhythm. And at the heart of that invisible scaffolding lies something both simple and profound: gravity. Gravity is not a thing we can see. We cannot touch it, hear it, or catch it in a jar. But it's always there, a presence that shapes every orbit, holds every star, and bends every path through space. Newton called it an invisible force. Einstein called it a bending of space-time. But for all the technical definitions, gravity remains, for most of us, a quiet truth. The reason why the moon circles the Earth, why the Earth circles the sun, why your feet rest on the ground, and why comets always return from the edge of the dark. The sun holds 99.86% of the mass of the solar system. It is the gravitational anchor, a slow-burning furnace whose pull stretches across billions of kilometres. The planets, in turn, are caught in its grasp, each one falling endlessly toward it, but never arriving, caught in the delicate balance of orbit. That balance is not stillness, it is motion, motion guided by the curve of gravity, like a leaf swirling in the eddy of a slow stream. But the sun does not act alone. Jupiter, massive and ancient, is the second great sculptor of motion. Its gravity doesn't just hold on to dozens of moons, it shapes the behaviour of asteroids, nudges comets, and may have even prevented a planet from forming in the asteroid belt. Its influence reaches far beyond its own orbit. It is both protector and disturber, deflecting some objects away from Earth, pulling others into unpredictable paths. In the long history of our system, Jupiter has likely saved Earth from more than one cosmic impact, and perhaps, on occasion, sent a few our way. Then there are the Lagrange points, those magical places where gravitational forces balance just so. They are not objects, but locations, empty spots in space where a satellite or asteroid can remain, drifting gently, pulled equally by two larger bodies. Earth has Lagrange points with the Sun, so does Jupiter. Some of these points are populated, with spacecraft like the James Webb Space Telescope resting at L2, shielded from sunlight, always watching the deep dark. Others host Trojan asteroids, locked in shared orbits with planets, moving together like celestial companions who never quite meet. Beyond gravity's sculpting lies another force: inertia, the quiet insistence of every object to keep moving as it has. A comet that falls toward the sun from the distant Oort cloud does not stop when it gets there. It loops around and heads back out, pulled by gravity, guided by inertia, following a path that may take thousands of years to complete. Each orbit is a memory, not of thought, but of momentum. And yet, nothing stays exactly the same. Planets wobble in their orbits, pulled by the subtle gravities of one another. Moons drift. Our own moon is moving away from Earth by about 3.8 centimetres per year, slowly changing the length of our days. Tides shift, axes tilt, orbits precess. Over millions of years, these tiny changes add up, redrawing the solar system's clockwork in slow, unpredictable ways. Even gravity itself, so steadfast, is not always enough to hold things in place forever. Some comets are pulled too close to the sun and break apart. Others are nudged by a planet's gravity and flung out of the system entirely. There are escapees, fragments of rock and ice that will spend eternity wandering the galaxy, untethered, whispering the story of the system that let them go. And yet the structure holds. For now. For us. It holds because of resonance, the way orbits can lock into harmony. Jupiter's moons, Io, Europa, and Ganymede are locked in a 1 to 2 to 4 resonance, meaning that for every orbit Ganymede completes, Europa completes 2, and Io completes 4. This is not coincidence, it is balance, a system of gravitational rhythms that prevents chaos, keeps tides flowing, and perhaps even stirs the oceans beneath those icy crusts. It holds because of distance, the way space gives room for motion to stabilise. The planets are not crowded. Their orbits are separated by enough space to allow for drift, correction, adjustment. In that space, gravity can guide without smothering. It can curve rather than crush, and it holds perhaps most beautifully because of time. Because the universe does not rush. These orbits are not perfect. These paths are not eternal, but they are long and slow and patient. They are stable enough for life to emerge, for moons to freeze and thaw, for storms to rise and pass, for us to watch. So tonight, as you lie still, think of everything that is moving. The Earth, turning softly under your body, the moon drifting slowly away. The planets, looping through space in arcs they've followed for eons. The comets, returning like long-lost messengers, all held together not by threads or ropes, but by gravity, a presence you never see, but always feel. Let yourself be part of that structure. Let your breath join the rhythm. Let your thoughts orbit softly, gently, like dust in the light. The solar system holds, and you are held within it, not by accident, but by the oldest law of motion, written not in words, but in silence. If planets could speak, they wouldn't shout. They wouldn't argue or compete. They would whisper, slowly, in long arcs of motion and waves of light. Each would speak with the voice of its own nature, shaped not by opinion or thought, but by weight, temperature, rhythm, and silence. And if you listened long enough, if you let the noise of the day fall away, you might begin to hear the tone of each one, not in words, but in feeling. Mercury would speak first, but briefly, in quick bursts darting close to the sun and back again, always in motion, always warm with radiation. Its voice would be high, fast, and a little nervous, like a messenger who has seen too much heat and doesn't stay in one place long enough to be comforted. Mercury is the smallest, the swiftest, and the most elusive, a planet caught between fire and shadow. If it had words, they would flicker. Venus, on the other hand, would speak slowly, not because it is calm, but because it is burdened. Its voice would be low, muffled, and endless, like heat rising from pavement that never cools. Venus would speak in pressure and poison, in the endless cycle of clouds thick with sulphur, in a storm that has lasted for hundreds of millions of years. It might warn you, gently but unrelentingly, that beauty and brightness can be dangerous, that behind its soft golden glow lies an atmosphere thick enough to crush and burn. Venus is not cruel. It is simply exhausted, always turning slowly through a haze it cannot clear. Then, Earth. If Earth spoke, you'd recognise the tone. It would be warm, layered, always shifting, a voice that carries forests and oceans in its breath. It would not shout, but it would sing, in rainstorms and wind, in heartbeat rhythms, in the slow tide of seasons. Earth is rare not because it is dramatic, but because it is balanced. Not too hot, not too cold, not too fast, not too slow. Its voice is steady, but not still. You hear it in bird calls, in crashing waves, in the whisper of leaves. Earth speaks like a memory you forgot you remembered, familiar, fragile, and alive. Mars would speak like a poet. Its tone would be dry, thin, and tinged with longing. It remembers water, though it no longer has much. It remembers warmth, though it no longer feels it. It might speak of rivers that vanished, of a sky that once held clouds like Earth's, of a time when it too might have had breath. Mars doesn't ask for sympathy. It simply offers stories, carved in canyons, etched in stone, buried in dust. Its voice is distant, but not without hope. After all, even now, dust devils still dance across its plains. And then there is Jupiter, the thunderer. But don't mistake that for volume. Jupiter doesn't raise its voice. It doesn't need to. Its presence alone carries weight. If it spoke, it would do so like a protector, deep-voiced, slow-moving, ancient. Jupiter is the storm keeper, the comet shepherd, the silent wall between Earth and chaos. It would not offer many words, but the ones it did would echo. It has seen more than any other planet. Auroras the size of continents, moons erupting into space, rings of dust and fragments. Jupiter would speak in gravity and magnetism, in the hum of radiation, in the slow pulse of something very old still spinning with purpose. Saturn would speak in elegance. Not proud, not loud, just graceful. A soft voice wrapped in rings, telling stories that span millions of years. If you listened closely, you might hear it speak of time. Not in days or years, but in orbits, in particles suspended in balance. Saturn is the archivist, the composer. Its rings sing without sound, and its moons, Titan Enceladus, speak with it, echoing whispers of liquid lakes and icy oceans. Saturn would never hurry. It would pause often, letting silence say just as much as speech. And far away in the colder dark, Uranus waits. It does not mind the silence. If it spoke, it would do so softly, almost shyly. It is the introvert of the solar system, spinning on its side, keeping its storms quiet, reflecting very little light. But don't mistake quiet for absence. Uranus holds secrets in the deep. Oceans, perhaps. Subtle heat. Slow storms that hide beneath its pale blue veil. Its voice would be inward, thoughtful, patient. It doesn't speak often, but when it does, it says things no one else can. Neptune, by contrast, would surprise you. Though it lives at the edge of the known, its voice would be sharp, fast, filled with wind. Neptune speaks with speed, the fastest winds in the solar system, and with pressure, turning carbon into diamonds beneath its storms. Yet its colour is soft, its glow gentle. It would speak of contradiction, motion inside stillness, chaos hidden beneath calm. Neptune would not tell you everything. It would let you wonder, knowing that sometimes mystery is its own kind of conversation. And then, in the far dark, a smaller voice, Pluto. It would not speak often, and its words would be quiet, distant, delayed by space and time. But when it did speak, it would tell you about loneliness, not with sadness, but with awe, about glaciers made of nitrogen, about skies that glow faint blue for a few brief hours, about how even the farthest places still carry heat, still move, still remember. Pluto's voice would be like an old postcard, faded, unexpected, still filled with meaning. All of them together, these planetary voices don't argue. They orbit, they hold, they wait. Each has its own mood, its own rhythm, its own truth. And you, a listener born of Earth, drifting beneath your own sky, get to hear their echoes, not with ears, but with thought, with curiosity, with awe. Tonight, let those voices keep you company. Let Mercury pass you a fleeting thought. Let Venus hum beneath your breath. Let Jupiter's presence anchor your chest. Let Saturn's silence trace rings around your dreams. Let Uranus and Neptune whisper from afar. And let Pluto wave, small and bright, from the edge of everything. They're not talking to be heard. They're just being. And that somehow is more than enough. There are facts so strange, so beautifully counterintuitive, that if you heard them without context, you might think they were science fiction or poetry. That Saturn could float, that Venus's day is longer than its year, that diamonds might fall from alien skies. These are not metaphors. They are real, measurable, repeatable truths, and they are scattered throughout our solar system like small miracles, not meant to be believed at first, but meant to be wondered at. Let's begin with the one that always raises eyebrows. Saturn would float in water. That sounds absurd. A planet so vast, with rings that span hundreds of thousands of kilometres, floating like a pool toy. But it's true. Saturn's average density is lower than that of water, about 0.687 grams per cubic centimetre. That means if you could find a bathtub big enough, and the universe is full of things too large to imagine, Saturn wouldn't sink. It would bob gently, rings and all. Of course, such a thing could never happen. But the thought of it, that a planet of such size could be in some sense light, stretches the mind in a comforting way. Or take Venus, so similar in size and mass to Earth, and yet home to one of the most peculiar clocks in the cosmos. It spins so slowly that its day lasts 243 Earth days, while its year lasts only 225. That means the sun rises and sets just once in that entire time. And to make things stranger, Venus spins backwards. On Earth, the sun rises in the east and sets in the west. On Venus, it's the other way around, if the clouds ever allowed you to see it. And they don't. Venus is wrapped in an atmosphere so thick and so reflective that sunlight barely touches the surface. A day on Venus is not just long, it's hidden, smothered in pressure, bright from above but dark below. Now look to Jupiter, the gas giant that never quite became a star. Its storms are legendary, especially the Great Red Spot, a massive hurricane twice the width of Earth, swirling for at least 350 years, perhaps longer. We don't know exactly when it began, we just know it hasn't stopped. A storm that outlives empires, a reminder that on some planets weather doesn't pass, it remains, and it's not the only one. Jupiter is home to many such vortices, swirling in patterns both chaotic and stable, all suspended in an atmosphere with no surface, no floor. Just sky, upon sky, upon sky. And yet, far from this violence, in the frozen reaches of the outer system, we find strangeness of another kind, rain made of diamonds. Scientists believe that deep within the atmospheres of Uranus and Neptune, intense pressure and temperature cause carbon atoms to compress into diamond structures. These diamonds may then fall like hail, slowly sinking through layers of gas, possibly forming a diamond-rich core. It's not just a poetic image. Laboratory simulations on Earth have replicated the pressures and confirmed the chemistry. Somewhere, far beyond the sun's warmth, solid gems may be falling endlessly in the dark. On Titan, Saturn's largest moon, it rains methane. Lakes, rivers and seas carved into the surface aren't made of water. It's too cold for that, but of liquid hydrocarbons. The sky above drips with clouds of methane, and the surface carries the echoes of erosion, of seasonal floods, of ancient shores. Titan's landscape is in every sense alien, and yet strangely familiar. It mirrors Earth's hydrology, just shifted into another kind of chemistry. It's like looking at your own reflection, but slightly blurred, in the mirror of another world. Enceladus, another of Saturn's moons, has geysers, not of steam, but of salt water, laced with organic compounds, blasting from cracks in the icy surface and into space. These plumes are so persistent, so rich in material, that they contribute to Saturn's rings. A moon, tiny, frozen, barely visible, reshaping the very image of its parent planet with invisible fountains rising from what may be a subsurface ocean. And what about Pluto, once called the ninth planet, now a dwarf, and still full of surprises. When New Horizons flew past in 2015, it found nitrogen glaciers, blue skies, possibly an ocean deep below, and mountains made of water ice, standing tall in an atmosphere so thin you could stretch out your hand and touch vacuum. Pluto, cold and distant, remains geologically active. Not just a frozen relic, but a breathing, changing world, one that still holds on to heat despite orbiting at the edge of everything we know. And then there's Earth, the most familiar and the most improbable. The only planet so far with liquid water, breathable air, and life. The only one with plate tectonics and magnetic shielding. With a moon just the right size to stabilize our tilt. With an atmosphere just thick enough to hold warmth, but thin enough to breathe. Earth, as it turns out, may be the strangest of all, not for its extremes, but for its balance. For how everything holds just enough, but not too much. For being, against all odds, possible. None of these facts are made up. None of them are exaggerations, and yet they feel like fiction. Because fiction often borrows its most powerful images from the cosmos, and the cosmos in return offers truths that no fiction could have invented. So tonight, as you lie beneath your ceiling or the open sky, remember that reality doesn't need to shout to be magical. It just needs to exist, gently, strangely, beautifully. Saturn floats, Venus spins backwards, Jupiter's storm never ends, and you, quiet, human, fragile, are surrounded by truths that sound like dreams. Let those impossibilities wrap around you like a blanket. Let them keep your thoughts company. You don't need to understand them. You don't need to explain them. You only need to know they are true. And they are waiting for you, just beyond the clouds, spinning in the dark. You are on a planet tonight. A blue one, fragile and warm, spinning quietly through space. You don't feel the motion, but it's there. A silent turning that has carried you through every sunrise and every dream. It is easy to forget this, easy to feel small, easy to believe the night is still. But above you, beyond the atmosphere, beyond the moonlight and the scattered clouds, everything is moving. The solar system never sleeps. It doesn't blink or pause or hesitate. It spins, flows, orbits, and breathes. Not with lungs, but with gravity and light. The Earth turns on its axis once every 24 hours. The Moon orbits us every 29.5 days. The Earth orbits the Sun once a year, and the Sun in turn dances through the galaxy, dragging every planet and moon and comet behind it in a vast spiralling waltz that takes 225 million Earth years to complete a single lap. You are part of this dance. You always have been. Tonight perhaps your thoughts are restless. Maybe they move in circles, chasing each other like moons around a forgotten planet. But in this moment, you are still. Not because the world has stopped, but because it has embraced you. The chair beneath you, the bed, the air against your skin. All of it rests in the arms of gravity, and all of it moves gently through a darkness so vast that it becomes calm just by its enormity. There is comfort in motion when it is slow, in distance when it is silent, in time when it's patient. The planets do not rush. Mercury zips closest to the Sun, its years short and sharp, but its surface bears the scars of time, not of hurry. Venus turns backwards so slowly that a single day there could hold all of Earth's seasons. Mars remembers its rivers. Jupiter holds storms older than our oldest books. Saturn cradles rings that may one day fade, but for now they spin. Thin, bright, impossible. Uranus rolls like a whisper. Neptune howls beneath a blue veil, and Pluto watches from afar, still turning, still changing long after many stopped looking. No planet asks to be seen. No moon performs. They exist in their own rhythms, moving in silence, orbiting because that is what they do. You too orbit, the centre may change, but the movement remains. Around family, around memories, around thoughts that return when you least expect them. And perhaps that's what makes sleep such a wonder. It is not just rest. It is drift. A journey inward, but also outward, to places thought cannot reach unless you let go. It is your own personal orbit, a path you follow without effort, one that brings you closer to something peaceful, whether it's memory or dream or just the quiet stillness of being held. Tonight, as you spin with the earth, know that the stars are still out there. They do not twinkle because they know you are watching. They do so because of physics, distance, and diffraction. But even knowing that, they feel like companions. Some of their light left its home before humans ever walked. Some will not arrive until long after we're gone. But for now, a few of those photons, just a few, have landed here, with you. On your windowsill, on your skin, in your memory. And even if the sky is cloudy, even if you cannot see them, you're still bathed in motion. The turning of the planet, the movement of air, the slow shift of shadows. You're not separate from the solar system. You are inside it. You're made of it. Atoms forged in stars, breath sustained by light, thoughts flickering like magnetic pulses in your own small orbit of brain and being. In this system, nothing is truly still. Even the rocks in deep space, even the dust between the planets moves. They fall toward something. They circle. They spin. And so do you. If you are awake now, that's okay. Some journeys begin in stillness. Some take longer to reach. But you don't need to do anything to be part of this motion. You don't need to understand or prove or plan. You only need to be here, listening, turning, breathing, held. You sleep on a world that turns. You rise with a sun that never really rises. It is the earth that spins you toward it. You fall asleep beneath a sky that stretches farther than your lifetime, but closer than your breath. The solar system holds you, not as its centre, but as its passenger. A quiet voyager, wrapped in the arms of a spinning blue world. And tonight, all you need to do is rest. Let gravity do the work. Let time take the wheel. Let thought unravel like starlight across the void, and sleep well, spinning in the dark.